Hi, welcome to Space Lunar Academy. This is Mr. Colossa, and today we're doing video number 2 of the exam revision on electric circuits. So note this is a video for grade 11 and grade 10 learners. If you're doing grade 12 and you do not understand electric circuits, this is perfect video for you. But if you are looking for some resource to um, revise for grade 12 only, then you can check one of my videos for grade 12 in electric circuits, or you can check other resources here on other channels or maybe my channel. But if you do not understand electric circuits and you want to understand the basics of electric circuits, this is a perfect video for you. You can watch, feel free to watch this video. Kindly note that this is video number 2, as I've already said. This is video number 2. And in other words, if you haven't watched the first video, feel free to first watch it, because it will make sense to watch the second video, and it will make even more sense to watch this video after watching the first video, because most of the concepts I have explained them in the first video, like in video 1 of the revision. So we're continuing with the revision now. And we're given 2 circuits here. So they say refer to circuit A and B below and answer the questions that follow. What questions? These are the questions that we'll be answering today. Where are the marks? Here are the marks. It's 11 marks out of 11 marks. Okay, let's go up and try to analyze. Let's analyze these circuits. You are given 2 circuits, circuit A and circuit B. So circuit A is a parallel circuit. We call it a parallel circuit. Why is it a parallel circuit? That's because the resistors that are given here, they are in parallel to each other. Remember, I'm assuming you watched video number 1. So video number 1, we said that you know what a parallel circuit. Parallel circuit was where resistors, if you have a resistor here, then a second resistor would be right below this one, the first one. So they are parallel to each other if they are in this format. But if they are following each other, if there's one after the other, like this way, then they are in series. They are no longer in parallel, they are in series. For example, circuit B, this resistor is in series with this resistor. So this is a series circuit. We call this a series circuit because the resistors are in series. Okay, that's great. That's great. Let's analyze. We said current starts from the positive terminal. In other words, assume current is like water. The same analogy will always work. The same method works. Current starts from positive terminal and then it moves. And at this point, it branches out. One of the current flows through this side. It goes through the 1,5 ohms. And the other current goes through this 1,5 ohms. And then this one goes up. This is like water. Then at this point, it branches again. It combines. The current from this side combines with the current from this side to form the same current that entered at this region. Hope it makes sense. Still the same thing we said in video number 1. Keep that in mind. So the current returns back to the cell. The circle continues. It means that this current will keep on flowing. It will keep on flowing around the circuit, up until this 9 volts is finished. Okay, now we understand what happens in circuit 1, that is in circuit A. So now let's take a look at circuit B. In circuit B, remember I said circuit B is a series circuit. Why? Because the resistors of circuit B, of the circuit, they are in series to each other. One is after the another resistor. They are following each other. It's like they are tied to each other by some string or something. There's one after the other. Hope it makes sense what I'm trying to say. Okay, so the same thing happens here in circuit B. Current flows from the positive terminal. Remember, the longer terminal is the positive one. So and then it passes through 2 ohm resistor. passes through the A2, meaning ammeter number 2, passes through the A4 ohm resistor, and then goes back to the negative terminal of the battery. Does that over and over and over again up until the 9 volts is finished. Remember, the current that passes through 2 amps or 2 ohms. So let me clean this first. The current that passes through this resistor is the same as the current that passes through this resistor. Why? Because in series resistors, I1 is the same as I2. In other words, the current that is here is the same as the current that passes here. So it means the rate at which this water flows is the same. It doesn't matter if the resistances are not the same, but the rate at which this water flows is the same for both of these resistors. Meaning current is the same. Current is the same in series resistors. But in parallel resistors, current may not be the same. It is only the same in parallel resistors. It is only the same, only the two resistors are have the same resistance, like in this case. So the current of this part is the same as this one, just because the resistance value is the same. But if the resistance value was not the same, maybe we had 5 ohms here and 1,5 ohms, then the current wouldn't be the same. It would split according to the ratio of the resistance. Hope it makes sense. For resistors in series, current is always the same at all points. But for resistors in parallel, current is not the same. It is only the same, or it's only equal when the resistance the resistance values are the same. Hope it makes sense. So what are these? We said these are voltmeters. These are voltmeters. They are devices that we use to measure voltage, meaning the energy in volts that is used by each resistor. Because we said the resistors consume energy. They use some energy. So this energy is in volts, because voltage is the energy provided by the battery so that current flows. Okay, let's go to the questions. I'm assuming that this is a perfect analysis of both circuits before we do the calculations. Now let's try to answer these questions. The first question, we are required to determine or define the term EMF. What is meant by EMF? Well, let me explain this. If we were given 9 volts placed next to the battery or a cell, this is a cell, it's not a battery, because there's only one terminal, positive terminal, and one negative terminal. There's no other negative and positive terminal. So 2 or more cells, this is a cell. But if there are 2 or more, they make up a battery. This is a battery. Hope that makes sense. These 2 are cells. These are 9 volts 9 volt cells. They are more like a cell, a battery. There's nothing different. But a cell is smaller than a battery. A battery is just a group of cells. Okay, that matters. That matters. That's why I mentioned that. Maybe you may be asked to say whether this is a cell or a battery. I don't know, but it helps to know that. Okay, we're trying to define what EMF is. EMF is the maximum amount of a battery or a cell it's maximum amount of voltage that a battery or a cell can supply to the circuit. So in other words, this cell will provide a maximum amount of energy, which is in volts. It will supply this 9 volts to the circuit. So this is the maximum amount of voltage that this battery or this cell can supply to this circuit. It can only provide 9 volts. So 9 volts, or this 9 volts, or EMF is the maximum amount of voltage that a battery or a cell can supply to the circuit. So this 9 volts is said to be the EMF because it is the maximum amount of voltage that this cell will supply to this circuit. Hope it makes sense. So that's EMF. EMF can also be defined as the work done by a battery. It's the work done by a battery to move a charge around the circuit. It can also be defined as the work done by a battery, where a battery in moving a coulomb of charge around a circuit, of charge around. Trust me, my writing is very beautiful when it's my handwriting is very beautiful. It's just my pen. Let me blame the pen and this tablet that I'm using to write it. Let me just blame it. This is not my handwriting. It's bad. This one is bad. It's not my original, but it doesn't matter. As long as you can see this, that's all that matters. Work done by a battery in moving a coulomb of charge around a circuit. Well, that's the definition of what EMF. Work done means energy. So it's the energy that is provided by a battery so that it can move charges around a circuit, which was the same thing as what I was saying before. That is the maximum amount of voltage that this battery will supply to the circuit. Hope that makes sense. Okay, let's clear up this. Okay, let's clear this up. Yes. Let's see. So we know EMF is the maximum amount of energy in volts, or is the maximum amount of voltage that the battery or a cell can supply to the circuit, or is the work done by a battery or a cell in moving a charge around a circuit. It's this amount of energy that is needed to move a charge around a circuit. Okay, amount of energy. Okay, let's calculate the total resistance of circuit A. Let's go to circuit A and take a look at circuit A. Oh, they want us to find the total resistance of the circuit. It means we only have these two resistors. And we want to find the resistance of the two resistors. They are in parallel. So remember, we said that here is the formula. 11.2. If you want to find the resistance of parallel resistors, we use the formula 1 over Rp is equal to 1 over R1 plus 1 over R2. How many resistors? There are 2. So this is enough. If we had 3 resistors, we would say plus 1 over 3. If we had 4, plus 1 over 4. You see, the formula just keeps on extending. But we have 2 resistors, so we just will end here. 1 over Rp is equal to 1 over R1 was 1,5 plus 1 over 1,5. So if you add 1 over 1,5 plus 1 over 1,5, you get 1 over Rp to be equal to 4 over 3. If you press your calculator to do some maths, you get 4 over 3. Then from this 4 over 3, you cross multiply. The same process as in video number 1. We're trying to solve for Rp, so we cross multiply. So you cross multiply. So 1 will multiply the 3 and Rp multiplies the 4. So 4Rp becomes 3. Then divide by 4 because we want to find Rp. 4 cancels. And Rp becomes 3 over 4, which is the same thing as 0. 0.75 ohms. Oh yes, hope that part makes sense. So that is our RP, the value of RP, meaning this is the value of the total resistance of circuit A, because these are the only two resistors for circuit A, this one and this one. So we're done. Let's take a look at the third question. We answered this one. We said it's the maximum amount of voltage or energy that is needed to move a coulomb of charge or to move a group of charges around the circuit. So the total resistance we already calculated for circuit A. Now we are required to consider circuit B. In other words, let's take a look at circuit B. And we are to write down the reading on A2. What will be the reading? What will be the value of current that will be read by ammeter number 2? So look at this. This is current. This is circuit number B. We said this is a series circuit because the resistors are in series. Great. So current will flow. Remember, we said current will flow like this. If it's 1,5A, it will go as 1,5A and pass through this 2 ohm as 1,5 amps. Nothing changes. Remember, we said I of here is the same as I in here, meaning current of 4 ohms is the same as current of 4. So this will also become 1,5 amps. It's the same throughout the circuit. Remember, so resistors in series have the same amount of current. So the reading in A2 will be the same as the reading in A1. This will be the same. Okay. They said write down. They didn't say calculate. Look at the marks. Now imagine sweating, trying to find current, trying to calculate for just 1 mark. Nah, write down. Let's read the question the right way. So A2 is simple, 1,5 amps. They just want to test the understanding that we have on electric circuits, because we understand that the same current flows in here. Okay. Now let's answer this one. They say we are to calculate the reading on V1. What will be the reading on voltmeter number 1? Where is voltmeter number 1? Meaning, what will be the voltage that will be read by this voltmeter? What will be the energy that is used by this resistor? In other words, what is the voltage that is used by this resistor? That's what they are trying to say. Okay, that's dope. We know that the current, they want the voltage. You know current is 1,5 amps. Why? Because it's the same current that flows passing through this. And you know the resistance. So according to Ohm's law, if we want to find V1, it should be I times R. Learn this formula. It's very powerful. It's very powerful. It will help you do a lot of calculations. Okay, so let's not waste time. Let me just do the calculations right here. V1 is equal to I, which is 1,5 times R. R with the value of R is 2. That's 2, which is equal to 3 volts, because 1,2 times 2, 1,5 times 2 is 3 volts. What does this whole thing mean? It means that out of this 9 volts in this battery, 3 volts is used by this resistor. What? It means this one is using 3 volts. Okay. This one is using 3 volts. If this one is using 3 volts, it means this one is using the remaining 6 volts, because the total voltage here was 9. So 3 plus 9 makes so 3 plus 6, 6 plus this 3 gives us the total of 9. I hope that makes sense. Keep that in mind. It's very important. Okay. Now let's do the last question. They say if a third resistor of 1,5 ohms is placed in parallel with the existing resistors in circuit A. In other words, if we add another 1,5 ohms resistor in parallel again on circuit number A, would the total current in the circuit increase, decrease, or remain the same? Explain your answer. How many marks? That's 3 marks. So we have the 1 mark would be for decrease, increase, or remain the same. Then 2 marks would be for explaining. So let's analyze the question. What are we being asked here? They are saying that if we add another resistor of the same value, 1,5 ohms, they are asking what will happen to the total current of the circuit. What will be there? What happens to the current? What happens to the current of the circuit? Well, remember, if we add more resistors in parallel, remember, I think I said this in video number 1, resistors in parallel tend to decrease the total resistance of a circuit. In other words, they increase current. So current will increase in this case. Current will increase. So current will increase. Increase. That's the last question. So current will increase. Why? Let me go back and analyze. Maybe I'm not making sense to some of you, my fellow fans. So I don't want to disappoint you. I want to do my best in trying to explain everything. Okay, so I'm saying it is said that adding more resistors, this resistor is in parallel to this resistor and in parallel to this one. So if I add the fourth one and the fifth one, then a total resistance RT reduces dramatically. The more I add resistors in parallel, the more I reduce resistance of the circuit. But the more I add resistors in series, the more I increase total resistance. I hope it makes sense. The more I add resistors in parallel is the more I decrease the total resistance. So if total resistance, if RT it drops, it means I total will do what? Will increase. Why? That's because of Ohm's law. Look at Ohm's law. Ohm's law states that the potential difference across a conductor or a resistor is directly proportional to the current that passes through this resistor or a conductor at a constant temperature. So in other words, current is equal to V over R. If this one keeps on dropping, meaning if this one decreases, remember I said if we add more resistors in parallel, we are decreasing the total resistance of the circuit. If R decreases, I will do what? Will increase. Why will I increase? It will increase because these two are inversely proportional. This one is on the denominator and this one is on the numerator. It's up there. When current, sorry. So this is how we can explain this. According to Ohm's law, checks Ohm's law, an increase, a decrease. Sorry, let's not start here. Let's start from the beginning. I think this is not how this is kind of a conclusion. Let's try to make it make more sense. It's a comma. Adding more resistors in parallel leads to an a decrease in total resistance of the circuit. When you add more resistors in parallel, you will get a decrease in total resistance of the circuit. Then you say what? When resistance decreases, current increases, since they are inversely proportional. They are inversely proportional. Since they are inversely proportional according to Ohm's law. We are working hard for that 2 marks. This is not that long. This is not a long explanation. Remember, this is the screen of a laptop. This is me writing randomly. But if you write this down on your book, it will become shorter, and maybe it will take 2 to 3 lines. I don't know. Maybe 2 lines max. I don't know. But you can shorten this. You don't have to write everything. Yeah. This is the explanation, but I wrote everything so that you understand. When you add more resistors in parallel, you are reducing the total resistance of the circuit. And if you reduce the total resistance, it means current will increase. Why? Because current and resistance are inversely proportional. This means that if current goes up, resistance goes down. If resistance goes down, current goes up. Hope it makes sense. So this is all for this video, because this was the last question of this circuit, or of this video, the last question on this video. If you like the content, just click the like button, leave a comment, compliment me if you feel like doing so. If you feel like I need to do some improvement or make an improvement, just tell me to do so. My followers told me to change the language. I was teaching this course before using my home language, which is isiXhosa. So I was teaching it in isiXhosa. So more of my viewers wanted me to use English. So that's why I changed. So that's one of the comments I received. Hence, I changed the language. And if you also would like me to make some changes, just let me know. Or if you would like to compliment me, leave a comment, say whatever you want to say, how you feel about this lesson. Share, subscribe, leave a like button. Oh, sorry, leave a like. And see you in the next video. Thank you.